Bismillahirrahmanirrahim. Hello everyone, I'm Dr. Mohsen, and today we will discuss the multispectral classification in the course of remote sensing and GIS. So, in the process of assigning individual pixel of multispectral images to categorize on the basis of spectral reflectance characteristics. Multispectral classification, the findings include land use land cover or for the purpose of land use land cover classification, vegetation type, geological terrain, mineral exploration and change detection. Classification inputs include multispectral imagery like Landsat, thematic mapper or airborne sensors. Multi-sensors include optical, thermal and radar. Multi-temporal include time series, seasonal effect, summer and winter scenes. Texture measures, low-level image processing results, local contrast, digital number variability, and etc. Ancillary data include DS information, thematic maps, digital terrain models. So the multispectral classification in which the input is the digital numbers of each pixel in several bands, multi-dimensional feature space, possibly or hopefully some physical knowledge of the study area or a selected site. So the technique used are the supervised and unsupervised classification. In unsupervised classification, the computer or algorithm automatically groups pixels with similar spectral characteristics on the basis of mean, standard deviation, covariance matrices, or the correlation matrices into unique clusters according to some statistical determined criteria. The analyst then relabels and combines the spectral resolution into the information or the based on the expert knowledge of the field or the study area. But in case of supervised classification, identify known priors through a combination of fieldwork, map analysis, and personal experience as training sites. The spectral characteristics of these sites are used to train the classification algorithm for eventual land cover mapping of the remainder of image. Every pixel, both within and outside the training site, is then evaluated and assigned to the class of which it has highest likelihood of being a member. Actually, in the training data or the already ground truth data is used to define the classes for the classification. An unsupervised classification objectives group multi-band spectral response pattern into clusters that are statistically separable. Try to define a small range of digital number fixing one cluster that is set apart from a specified range combination for another cluster. All pixels in the same cluster will correspond to some initially unknown ground feature or class. Generate n-dimensional intensify space, fill space, search for cluster, and the problem includes thematic mapper requires 2567 cells in cluster space. Solution is iterative schemes based on the k-mean or ISO data clustering techniques. Typical results of unsupervised classification include cluster 1 to cluster 15 and thematic mapper bands 2, 3, 4, 15 classes. Problem: poor interpretability, relate different cluster to meaningful ground categories. In case of unsupervised classification, as we are discussing, maximum number of clusters is automatically determined by the parameters selected in processing, not by the number of classes present in the scene or wanted by the user. Typically result, many individual areas represented by cluster do not appear to correlate with what is present in the scene. Result is rather artificial subdivision of spectral response from small segments of the surface. Slight variation in the surface orientation change the reflectance or the influence of mixed pixel. So the conclusion about the unsupervised classification is too much of generalization. Cluster only roughly match smooth of the actual class values mainly as a guide to the spectral content of the scene to aid in making a preliminary interpretation prior to conducting the much more powerful supervised classification procedure. In case of supervised classification, everything in nature has a spectral signature which can be used to separate feature and recognize surface material. Spectral signature may change over time and space. The balance of reflection, transmission, and absorption is wavelength dependent. Water has its own reflectance, vegetation has its own, and vegetation has different growth stages. So these are the spectral signature that can be used to identify the and here presented water, green grass, dry grass, and the soils. Classes are recognized by human operator in scene from prior knowledge such as personal experience with the region in question, thematic mapper, or on-site visits. Training sites area representing each known land cover category are located and circumscribed by polygonal boundaries drawn on the computer screen. For each class, mean value and variance of the digital number for each band used to classify are calculated from all pixels enclosed in the site. Digital number plotted as a function of the band sequence form is a spectral signature, a spectral response curve for the class. Classification now processed by statistical processing in which every pixel is compared with the various signature and assigned to the class whose signature come closest. Supervised classification flow image data set to pixel information digital number where the water, sand, forest, urban or training stages are uh, given. Then the classification stages, the digital number 1, 2, 3 to 5. So the output stage presented maps, tables of area, data GIS at the file type of class is presented. Where a digital number is replaced by the category or the type of the classification. Training stage selecting ROIs like alpha, alpha, cotton grass, and the fallow. Training stage source of information, the image itself together with image understanding capabilities of the user, additional knowledge of the user, information from maps or GIS, knowledge obtained by visiting part of the scene or the field strip, effort of training, choice of training site is crucial for scene success of classification as much as but not more than necessary. Training must be complete and representative, theoretical minimum per class or number of bands. Practical advice, number of bands, multiple of 10 to 100. Training stage signature comparison chart is presented here. Water, casinos, stand and strand, etc. Signature comparison chart is presented again here, and we will also discuss in detail when we will perform this supervised and unsupervised classification practical using Eradas image software. Training stage results information over the expected digital number for every class in every band, mean, minimum, maximum, standard deviation, and distribution is presented, and the class digital number are replaced with the type of class like urban, U, sand, corn, hay, water, and forest, etc. Post-processing of training region, example, an incidental boat in a training area, water will widen the class considerably. Countermeasures, analyze histogram of class in all bands, edit class boundaries in all bands. Example, histogram or urban thematic mapper 7, close to normal distribution, no editing required, was generated from thematic machine over Holland. Uh, A training sample for water over sea and river looks bimodal might indicate that sea and river can be distinguished. Check if other bands do also show a bimodal histogram. Water TM4 histogram shows a long tail to the right. Knowledge Knowledge on interaction of electromagnetic wave with the water tells us the reflectivity should be low NTM4. Entries to the right might be caused by boats or etc. Multiple spectral classification techniques include minimum distance to mean cluster, parallelepiped classifier, maximum likelihood classifier. Minimum distance to mean classifier, a rather simple technique based only on the mean spectral value of each band. For each pixel to be classified, compute the distance to the mean of each class in n-dimension feature space. Euclidean distance, Mahalanobis distance, L1 distance assign the pixel to the nearest mean. Cutoff distance leaves pixel unclassified if they are too far from any class. Advantage are simple and false. Disadvantage is the non-consideration of variance within the class. Pixel 2 would be classified as sand, although it falls into the scattered area covered by the airburn. In this technique, parallel pipe classifier, also box classifier, compute minimum and maximum values for every class in every band, and it defines n-dimensional decision region like rectangular box or hyperbox. The variance in class considered via the compactness of the region. The problem associated with this are the ambiguity of classification in region overlaps. Decision regions are rectangular and thus often much too large, especially in case of class with the high covariance. See a cat H as a hay in case of hay. Example pixel 1 is classified as a hay instead of car. Editing of signature become crucial. Covariance is rather frequent phenomena in multispectral imagery. Problem can partially be solved by modification of the definition of decision region, step border, rooted region, but still no assumption is made on the statistical distribution of spectral response pattern within the class. In case of maximum likelihood, use variance and covariance of spectral response pattern within the training sites. Assumptions are normal distribution or Gaussian distribution. Each class is characterized by n-dimensional mean vector, n and covariance matrix. In 2D, this leads to bell-shaped. In 2D, this leads to bell-shaped surface probability density function. Compute the probability of a pixel belonging to a certain class. Pixels assigned to the class with the height probability are unknown if all probability values are too small. The drawbacks are the amount of computation is very high or required a lot of work. Use of additional GIS information. Agriculture in the Cambridgeshire, England, TM data results of standard pixel-wise classification. Field contains several land cover types due to within the field heterogeneity. Boundary pixel between land parcels often belong to superior land cover types. Same data combined with GIS data result of a pair parcel-wise classification. One type of land is determined from the statistical analysis of classification in each parcel, and this is more reliable, consistent result. This is the Holland data, band 321 composite image of the thematic mapper data. Data of the training areas, water, grow, Ian, casein, stat, and strand values were collected to train for the classification of the image. Results of the maximum likelihood classification thematic data on the Zoid Holland is water, and this is the final map that is based on the maximum likelihood classification under supervised classification. Classification post-processing include problem. Result of classification looks rather noisy. The reasons are the separability of classes, pixel belonging to non-trained class makes pixel sensor dropouts. Solution include filtering of image, no arithmetic processing, logical operations, or the media filtering. Post-classification smoothing examples are presented here, water and all other things, to improve the image further according to the information. Remote sensing thematic accuracy, correctness of the classification results, internal verification is performed, analysis of classification of pixel within training regions, definition of other and large training regions, comparison with the result of classification. External verification include comparison with ground truth or the GIS, thematic maps or the field trips or the ground truthing data. Quality of ground truth is often not known or insufficient. Problem of mixing of the pixel. This is the error matrix, also confusion matrix and contingency table for the accuracy assessment of the mapped classification. Columns data as ground truth data, row data as the result of classification. So here there are two types of accuracies are collected: the user accuracy or the producer accuracy, and then the overall accuracy of the system based on the diagonal of the values presented on it. The column represents ground truth data, and the row presents the results of classification. Total number of pixels analyzed are 83,229. Diagonal elements, correct classification, ideal confusion matrix is equal to diagonal matrix. Non-diagonal elements in column, error of omission, exclusion, pixel wrongly assigned to the class. Non-diagonal elements in a row, error of commission, inclusion, pixel missed and assigned to other class. So the best values will be the presence on the diagonal of the this matrix. Columns is equal to ground truth, row is equal to results of classification. So here the accuracy of the class 3 is verified. So the total sample were 3 were placed in the class 2 and 34 were correctly placed on this, and the 2 another class and 129 to another class. So the accuracy uh, was measured in two terms: user accuracy and producer accuracy through the column combination and through the row combination. 3708 pixels were classified as class 3. The ground truth shows 3535 pixels as class 3. 3401, the pixel classified as class 3 are confirmed by the ground truth. 204 of the pixel classified as class 3 should be class 2 according to the ground truth. 1 to 9 pixels should have been classified as class 3 but were classified as class 5. Error of omission for class 3 is equal to 3.8%. 3.8% belong to this class were classified as belonging to other class. 96.2% of the class 3 pixels were found in the classification procedure. Error of commission for class 3 is 8.3%. 3% of the pixel classified as belonging to this class to in fact belong to other classes. So the 91.7% of the class 3 pixel are in the fact class 3. So the overall accuracy is estimated through the diagonal estimation. As correctly placed samples divided by the overall information or the correct overall collected samples. While accuracy of this map is 98.2% or 1 minus 0.0182. Sum of diagonal elements compared with the number of ground truth images might be largely influenced by one dominant and reliable class, often water, thus often too optimistic. Thank you very much. If you have any question, we will discuss it on the Google Meet further. These are the lectures that are also available to you for the repeated understanding and the learning about the material. थैंक यू वेरी मच. आप कोई भी क्वेश्चन है, कोई भी चीज़ है, तो गूगल मीट पे आप मुझसे पूछ सकते हैं ड्यूरिंग द क्लास, या हमारा जो व्हाट्सएप ग्रुप है कोर्स का, उस पर भी आप मुझसे पूछ सकते हैं.